Hello. So we are starting section 8.2, and it's going to again cover 2 days. This one feels a little bit bigger than our first section on parabolas. We're talking about ellipses and circles here. So this whole chapter is about defining things by distance. So how can we define what an ellipse is by distance? By this is a great visual. So imagine putting in two pins anywhere on a piece of paper, and then having a loose string. Take a pencil and put it inside the loop of the string and pull it taut, and then drag it all the way around, making sure that you keep the string straight. If that occurs, if you could do that, what you will have drawn is an ellipse. The So for a circle is really just a special type of ellipse. If these are called foci, one focus here and another focus here. If these two come together and become just one point, then when you drag that string around and draw it, you'll get this. So a circle is really a special case of an ellipse. It's an ellipse where the two pins are together in one single point, and we call that the center. But the mathematical definition, back to ellipses, the mathematical definition is it's the set of all ordered pairs where the sum of the distances to each foci are the same. So, for example, again, like right here, this is one particular point on the ellipse. If I took out my ruler and measured this distance and measured this distance and then added them together, and I get a new number. If I pick any other point on this ellipse and measure both of those distances again and add them up, I will get the same sum. Here is more about ellipses. So these two ellipses are orientated horizontally. They can also be vertical, up and down. The center, of course, is right in the middle, and it has two foci, a focus on one side and the other side of the center. They are in plural as foci. They have two vertices, one vertex on the edge and one vertex on the other. But the major and minor axis. So, however, an ellipse has a long side and a short side, right? The long side is the major axis. So, if the major axis is going left and right, then the ellipse is like a horizontal ellipse. But if the major axis is going up and down, then it's a vertical ellipse, and that's the major axis. The smaller distance is called the minor axis. And here's another distance definition. So, any point on this ellipse, if you measure these two distances and add them together, that sum will be the same for any other point that you try to do that. So if you pick another point over here, measure these two distances and add it up, it's going to be the same as if you added these two up. And here is our new roadmap and this will again be on your quiz and test. You will have access to this whole thing, but I beg you to do the homework, because if you don't practice, it's going to take you 5 hours to do the test. So you really just put the practice in, and the test will be a breeze. So this is, you're focusing on here, but only pluck out the things that you need. Some things to mention: the center is HK. So in parabolas, that was the vertex, but parabolas don't really have a center, but ellipses and circles do. So the center is HK, right in the middle. And notice the foci are always C away from the center, whether it's horizontal or a vertical one. It's always C away. And the vertices are always A away. So the A, B, and C are related by this Pythagorean relation. It's not the Pythagorean theorem with the triangle thing, but it's related to that. So A squared equals B squared plus C squared. I know this is a lot. You don't have to understand everything at once. You just have to be able to identify what you need and then go with it. The A value is always the bigger one. It's always the major major axis part. So remember, the major axis is the distance, this long distance here, which is horizontal. For this one, it would be this vertical distance. So whatever that distance is, A will tell you that. The semi-major axis, that means half of the major axis, is A. Half of the major axis. So the major axis is just twice A. So the distance from the center to the edge that right there is A. And the distance from the center to the edge, that's A, because I'm going along the major axis. The minor axis, so going along the short way from the center to the edge, that's B. And then from this one going from the center to the edge, that's B. Should have put this one from the center to the edge. Let's practice here. So first we're going to graph these things. And I've got 5 I want to quickly graph, or 4 I think. Notice all the equations equal 1. It's just a matter of, first of all, is my ellipse facing, is it horizontal or is it vertical? And it's all about where the major axis is. The major axis is always A. So here A is underneath the X part. So that means the major axis is horizontal. So this would be a horizontal ellipse. Here the A, the major part of the axis, is underneath the Y. So this would be the vertical one. Let's graph this. First of all, the center. What is the center of this ellipse? The center is HK, but there is no, I'm not subtracting any H's or K's. That tells me that HK is 0, 0. So the center is the origin, 0, 0. And then I'm dividing by 9. Here I'm dividing by 1. And remember, A is always bigger. So that means I'm dividing by A squared and B squared. So that means 9 is A squared. So that means A is 3. And since it's underneath the X, I have to go 3 to the left of the center and 3 to the right of the center. These are my 2 vertices, way over here and way over here. And then remember, 9 is A squared. Under here, this is y squared divided by 1. 1 would be B squared. So that means B is 1. So the minor axis is 1 away from the center. And then you just try to sketch as best as you can an ellipse. So here it is, centered at 0, 0. 3 to the left, 3 to the right. So the major axis is 6 units long, but remember 9 would go under here because it's A squared. If the major axis is 6, that means A is 3 and A squared is 9. There's a lot here. So again, this one, again, centered at 0, 0. So we will put a ordered pair at 0, 0. And underneath x squared is 4. And underneath y squared is 25. A is always bigger. So A squared is 25. And that's underneath the y. So I'm in this region. This is a vertical one. And since A squared is 25, that means A is 5. So to plot my vertices from the center, I would go 5 up and 5 down. And then this will tell me my minor axis. This is B squared. So B is 2. And I go 2 to the left from the center and 2 to the right. And I graph my ellipse. 1C. Look at this. A squared and B squared are the same. What does that tell you? This is a circle. The minor axis and the major axis are the same, so this will have to be a circle. But we'll graph it as, we'll treat it like an ellipse, but it's going to be a circle here. And the center, what's the center now? It's not 0, 0 anymore. Remember, the center is x minus h. I'm sorry, the center is hk. And the h is always related to the x, no matter what side you're on, and the k is always with the y. So the h is the x value, the k is the y value. So here, what's the center? The center is -1, 4. That's the center right there. And it doesn't, since these are the same, really doesn't matter which is a squared and b squared, but these are squares. So that means 4, I would go 4 to the left and 4 to the right. And then 4 up and 4 down. And then draw my ellipse. Let's see if it'll let me do this. It's may not look like a circle, but it's supposed to be a circle where the minor axis and the major axis are the same. Last one. What's the center here? The center is -2, +2. So I go to the left 2, up 2. That's my center. And is this facing horizontally or vertically? How is this orientated? The bigger number is underneath the x, so it's a horizontal one. This is a squared, so a is 6. I go 6 to the left. That's at -8. And I go 6 to the right, so that must be a +4. And then the 16 is underneath the y, so how much do I go up or down? I go 4 up and down. So from the center, I go up 4, and then from the center, down 4, and then draw my ellipse. All right, example 2. Eesh. Find the standard equation of an ellipse given these foci, and the major axis length is 10. Okay, so let's think this through. The foci are plus or minus 3, 0. That's two ordered pairs. So one focus is right here at 3, 0. The other focus is right here at -3, 0. So that means the center is again at the origin. The center has to be at the origin, and my ellipse looks something like this. But the key thing, that this is just a sketch, but since the foci are the two red dots, this tells me that I've got a horizontally aligned ellipse. So I'm ignoring this. Remember the a value is always bigger. So since this a is underneath the y, this is the vertical ellipse. So I'm focusing right here. And again, since I know my two foci are always equidistant from the center, so the center has to be 0, 0. So I know h and k. I have to find a and b. How do I do that? Well, the foci tell me. Well, at least they help. The foci are plus or minus 3, 0. Well, here the foci is h plus or minus c, k. So that means k has to be 0, doesn't it? And since h is also 0, c has to be 3. C has to be 3. So that's what I can pull from the foci. But then it tells me that the major axis length is 10. Remember, that's the distance along the longest route of the ellipse. This is 10 units long. Well, if it's 10 units long, then see the major axis is twice a. So 2 times a is 10, which means a is 5. And if a is 5, I know that I'm going to put 25 under here because a squared is 25. But I don't know what b is. So then I go here, the Pythagorean relationship. I know C, and I just found out A, so I can square those and get 5 squared equals b squared plus 9. Solve for b squared and plus or minus 14, because you always take plus or minus when you take the square root. But realize b is a distance. A, B, and C are all distances. So we would just reject the negative. It's just +4. B is just +4. But I don't really care about B because I have to find the equation and look at the equation. My equation requires h and k, which I know are 0 and 0. It requires a squared, so a squared is 25. And it requires b squared. So I really didn't have to take the square root. I could just stop right here. B squared is 16. So I plug in all my values and I get this. So this is the equation. This has two foci of +3, 0 and -3, 0 with a major axis length of 10.